I dot I gives you 1, I dot the other terms gives you 0. 0i plus 0j plus 0k, which is called 0 vector. This a dot b and b dot a will get cancelled because a dot b is equals to b dot a according to the commutative law of the dot product. If they have given the cross product, angle is nothing but sine theta. If they have given a dot product, angle is nothing but the cos theta. Hello dear students, a warm welcome to one and all. My name is Vibha, Mathematics faculty at Vidhyaashram Pre-University College, the Temple of Excellence, Mysuru. In the last session, we have learned many problems on the vector algebra of a vector product. That means a cross product, isn't it? In today's session, dear students, here we are having session number 8, and what are the problems we are going to study under this session is nothing but a similar types of problems we are going to have as a cross product. Let us look into the problem what they have given here. If a vector is equals to 2i plus 2j plus 3k and b vector is equals to minus I plus 2j plus k and c vector is equals to 3i plus j plus 0k are such that if it is not there, you have to consider it is a 0k, such that a vector plus lambda into b vector is perpendicular to c vector, then find the value of lambda. So it is perpendicular to c vector means you are going to take it as a vector plus lambda into b vector dot product into c vector is perpendicular. So you are going to take perpendicular of this will be is equals to, first let us take it as a vector. They have given it as 2i plus 2j plus 3k plus lambda into minus I plus 2j plus k dot c vector is 3i, I am taking here dot 3i plus j, correct. So which will be is equals to, first let us multiply lambda into what is that, a b vector. So 2i lambda into minus I, you can take it as I as a common factor. So therefore you are getting 2 minus lambda because plus into minus is minus into I cap. I hope you are getting this, and then you are going to multiply that. You know that I dot j is nothing but which is a 0. So let us move on to next I dot k. It is also a 0. So let us move on to the next term. 2j into I cap is 0. 2j into j, it is nothing but 1. So therefore lambda will be multiplied here. So plus 2 minus, you are having plus into plus is plus. You can take also 2 common factor, 1 plus lambda because here 2 into lambda into j cap. Understood? Similarly, you can multiply k dot k. So you can have it as plus, here it is 3. Again here lambda into k. So therefore 3 plus lambda into k. So with the dot product of what? With the dot product of into 3i cap plus j cap. So let us multiply now same thing. I dot I gives you 1. I dot the other terms gives you 0. So therefore 2 minus lambda into 3 you can have, isn't it? So 2 minus lambda into 3, again 2 plus 2 into 1 plus lambda into j, again plus 3 plus lambda into 0 because you do not have your k coefficient. K coefficient is 0. Now you are going to equate this to a 0. Why? Because they have given a plus lambda into b vector is perpendicular to the c vector. Is perpendicular to c vector means that dot product you are making it as 0. So therefore by equating this as 0, you are going to get it as, which implies that 2 minus lambda you can multiply, 3 2s are 6 minus 3 lambda. Again here you can multiply. So I have taken it as j, not taking j because j dot j gives you 1. That's it. Now 1 plus lambda, let us multiply 2 inside. plus 2 lambda, which is equals to 0. Since A vector plus lambda into B vector dot C vector, they have given it as perpendicular. We have equating to a 0. Understood? Now, you can simplify this. 6 plus 2 is nothing but 8. So, 6 plus 2 is nothing but 8. Minus 3 lambda plus 2 lambda is nothing but minus lambda equal to 0. Or otherwise, taking lambda to the right hand side, you are going to get it as lambda is equals to the value 8. That's it. So, this is what they have asked you to find out. I hope you understood this step, dears. Now, we'll be moving on to the next problem. What they've asked, find the unit vector perpendicular to each of the vectors A vector plus B vector and A vector minus B vector, where A vector is equals to 3i plus 2j plus 2k and B vector is equals to I plus 2j minus 2k. Now, here you are moving on to A plus B vector. They've asked you to find out the unit vector. So, unit vector is given by what? So, I am going to take like this. Since they are perpendicular, you need to find out the cross product of that. First, let us find out A vector plus B vector. What is that? Adding A and B. 3i plus I, which is 4i cap. Again, 2j plus 2j plus 4j cap. Plus 2k minus 2k will get cancelled. 0k cap. Next, we'll do it A vector minus B vector, which will be implying that 3i minus I, which is 2i cap. Again, 2j minus 2j plus 0j cap. Again, plus 2k. Minus of minus 2k is plus 2k. 2k plus 2k gives you plus 4k cap. Now, I am going to take it as, let us the cross product of this will be is equals to C vector. So, let C vector, because they have given it as perpendicular. So, therefore, let C vector is equals to A vector plus B vector cross A vector minus B vector, which implies that how to find out the cross product. Writing the first row as I, J and then K and the second row as A vector plus B vector coefficient of I, J, K, which is 4, 4, 0. 4, 4, 0 and coefficient of ijk of A vector minus B vector, which is 2, 0, 4. 2, 0, 4. Let us expand this one. What you are going to get it as? If you expand this, you are going to get it as, which implies that I cap into, leaving the first column, first row, 4 4s are 16, 0 into 0 is 0 minus j cap into, leaving the second column, first row, 4 4s are 16 minus 2 zeros are 0. Again, plus k cap into, you are leaving the third column, first row, 4 zeros are 0 minus 2 4s are 8. So, which implies that you can have 16 minus 0 is 16, I cap. 16 minus 0 is 16, minus into plus is minus 16 j cap. Again, 0 minus 8 is minus 8, minus into plus is minus 8k cap. Now, this is what the C vector, they've asked you to find out the unit vector. So, therefore, C vector, that is C cap, is given by, which is a unit vector of C vector is equals to C cap as C vector divided by magnitude of C vector. Now, what is the magnitude of C vector? Let us find out here only. C vector is nothing but 16. You can take, if you want, 8 common factor. 8 into 8 2s are 16. Again, minus 8 2s are 16. Again, 8 1s are 8. Divided by under the root of 16 squared plus 16 squared plus 8 squared. Right. So, let us evaluate this one. 16 squared will be is equals to 256 plus 256 plus 64. 256 plus 256 plus 64 gives you 576. Under the root of 576. So, 256 plus 256 here I am doing the calculation plus 64 under the root gives you root of 576 which is nothing but 24. So therefore writing the denominator as 24 you can get it as which implies that 8 into 2I cap minus 2J cap minus K cap divided by 24. You can divide 8 ones are 8 threes are. So the final answer you are going to get it as 2I minus 2J minus K divided by 3. And this is what the C cap, which is a unit vector of a C vector, where C vector is nothing but A vector plus B vector cross A vector minus B vector. I hope you understood this problem. Now we'll be moving on to the next problem, dears. What they've asked, show that A vector minus B vector cross A vector plus B vector equal to 2 of A vector cross B vector, that is 2 times of A vector cross B vector. Now let us take the left hand side. So left hand side implies that A vector minus B vector cross A vector plus B vector. Let us multiply this one. A vector cross A vector. A vector cross A vector. You are going to have plus into plus is plus A vector cross B vector. Again coming to the B vector minus B and plus A, which is minus B vector cross A vector. Next you are going to have minus into plus is minus B vector cross B vector, because be careful, in between you are having cross product. So which implies that you know already A vector cross A vector gives you 0. So which is nothing but 0. Now plus A vector cross B vector. Now dear students, according to the property of the cross product, A vector cross B vector can be written as minus of B vector cross A vector. So what is we have written? Minus of A vector cross B vector. This I can write it as minus of B vector cross A vector as A vector cross B vector. So therefore writing this one as plus A vector cross B vector. So this will become minus 0. B vector cross B vector is 0. So A vector cross B vector plus A vector cross B vector gives you 2 times of A vector cross B vector, which is your RHS. That's it. Therefore, taking the LHS, we have proved the RHS by knowing the property of the vector product. Okay. Now, we'll be moving on to the next problem. What they have asked, find lambda and mu if 2I plus 6j plus 27k cross I plus lambda j plus mu k equal to 0 vector. 0 vector is nothing but 0I plus 0j plus 0k, which is called 0 vector. Now, cross product is nothing but taking the determinant. Let us take the determinant. Since they have given, first row will be ijk, second row will be this one, which is 2, 6 and then 27. Third row will be coefficient of ijk, which is nothing but you are having 1 and then lambda and then mu. So which will be is equals to 0I plus 0j plus 0k. Correct, because they have asked you to equate it to 0 vector. Now cross multiplying this, you are going to get it as I into, leaving the first column first row, 6 into mu, 6 mu minus 27 into lambda, again minus j cap into, leaving the second column first row, 2 into mu, 2 mu minus 27 into 1, 27. So plus k cap into, leaving the third column and the first row, 2 into lambda, 2 lambda minus 6 into 1, which is 6, equal to 0I plus 0j plus 0k. Now equating the coefficient of ijk to 0. Now you can equate this to a 0. So which is therefore 2 mu minus 27 equal to 0 means 2 mu is equals to 27. Otherwise, mu will be is equal to 27 divided by 2. Now, equating the coefficient of j to a 0. Similarly, equating the coefficient of k, because I want to find out the lambda value. Here both mu and lambda is there, but here only mu and only lambda is there. They've asked you to find out the lambda and mu, so that I'm concentrating much on that rather than this one. Now here 2 lambda minus 6 equating to a 0, otherwise 2 lambda is equals to 6, 2 1s are 2 3s are, otherwise lambda will be is equals to 3. Therefore, you are getting lambda is equals to 3 and mu is equals to 27 divided by 2. Understood? So this is how you are going to find out the value. We'll be moving on to the next problem, dears. Find magnitude of A vector and magnitude of B vector if A vector plus B vector dot A vector minus B vector is equals to 8 and given magnitude of A vector is equals to 8 times of magnitude of B vector. Here you need to find out the magnitude of A vector and magnitude of B vector. Let us take whatever they have given. A vector plus B vector dot product of A vector minus B vector is equals to 8. Now let us multiply this. A dot A, again plus into minus is minus, A dot B, again plus into plus is plus, A dot B or B dot A, again plus into minus is minus, B dot B is equals to 8 they have given. Now this A dot B and B dot A will get cancelled because A dot B is equals to B dot A according to the commutative law of the dot product. Now here A vector dot A vector can be written as magnitude of A vector squared minus magnitude of B vector squared is equals to 8. Now they have given the condition magnitude of A vector can be written as 8 times of magnitude of B vector. Since you are having here magnitude of A vector square, that value also will become square. So therefore 8 times of magnitude of B vector whole squared. Okay. Minus magnitude of B vector squared is equals to 8. Otherwise, 8 8s are 64 into magnitude of B vector squared minus magnitude of B vector squared is equals to 8. 64 magnitude of B vector squared minus 1 B vector squared gives you 63 B vector squared. Okay, magnitude of B vector squared is equals to 8. Now you can cross multiply that, which will be giving you the value magnitude of B vector squared will be is equal to 8 divided by 63. 8 divided by 63. You can take the square root. So magnitude of B vector is equals to square root of 8 divided by square root of 63. Now you can have magnitude of B vector square root of 8 can be written as what? Square root of 4 into 2 divided by square root of 9 into 7. So which will be giving you the answer. 4 into 2 is 8. You can take square root of 4 which is 8. Square root of 9 which is 3. So therefore magnitude of B vector value gives you 2 root 2 divided by 3 root 7. If magnitude of B vector is 2 root 2 by 3 root 7, what is magnitude of A vector? Use the given condition which implies magnitude of A vector 8 times of magnitude of B vector which is 2 by 3 into root 2 divided by root 7. Otherwise you can write it as magnitude of A vector is equal to 8 2s are 16 divided by 3 into under the root of 2 divided by root 7. And this is a value of A magnitude of A vector and this is a value of magnitude of B vector. If you want, you can still write this one as magnitude of B vector is equals to 2 by root 3 into under root divided by 2 by 7. That's it. And that's what they've asked you to find out, dears. I hope you understood these steps also. Now, we'll be moving on to the next problem, dears. If the vectors A vector and B vector be such that magnitude of A vector is 3 and magnitude of B vector is root 2 divided by 3, and then A vector cross B vector is a unit vector, find angle between A vector and B vector. Dear students, if they have given the cross product, angle is nothing but sin theta. If they have given a dot product, angle is nothing but the cos theta. First take down whatever they have given. Given magnitude of A vector is equals to 3, magnitude of B vector is equals to root 2 divided by 3, and magnitude of A vector cross B vector they have given it as 1 because they have given unit vector. So sin theta will be is equals to magnitude of A vector cross B vector divided by magnitude of A vector into magnitude of B vector. Let us substitute the value. This is 1 divided by magnitude of A vector is 3 into magnitude of B vector is root 2 divided by 3. So which will be giving you 3 will get cancelled. Sin theta will be is equals to 1 divided by root 2. If sin theta is equals to 1 by root 2, you know already theta is nothing but sine inverse of 1 by root 2. Now what is sine inverse of 1 by root 2? 1 by root 2 is sine 45 degree. Then only sine inverse and sine will go. So the answer you are going to get it as, let me write that one, sine inverse of sine pi by 4. Because why I am writing in a radian, right? Degree or radian you can write it here. More preferably we are going to write it in a radian. So sine inverse sine will go. The answer will be is equals to pi by 4. So theta will be is equal to either 45 degree or pi by 4 is the value you are going to get it as. That is the angle. I hope you understood these steps also. Now we'll be moving on to the next problem. What they've asked. Find the value of I dot j cross k plus j dot I cross k plus k dot I cross j. You know already what is a cyclic order. Cyclic order, this is I, j and then k, right? So you can have cyclic order will be if I cross j is k, j cross k is I. Similarly, I cross k is minus j, j cross I is minus k, k cross j is minus I. If it is go ulta, if it is go like this, it is positive only. Correct. If it is go like this, it is negative. Understood? Now, you are going to get it as, let us take whatever they have given. I dot j cross k plus j dot I cross k plus k dot I cross j. Now let us take it as, see, I dot j cross k. You can see here j cross k is nothing but I cap. So j cross k is nothing but I cap plus j cap into I cross k. Ulta it is going I cross k. If it is ulta is going, it is minus j, which will be minus j cap. Similarly, plus k dot I cross j. I cross j is nothing but k cap. So into k cap. Okay. Now you can have I dot I. Let me write it as it is. I dot I plus into minus is minus j dot j plus k dot k. What is this dot product? I dot I is 1 minus j dot j is 1. K dot k is also 1. 1 and minus 1 will get cancelled. You are going to remain with the answer as 1. Therefore, the value of the given is nothing but 1. Understood? I hope you understood this cyclic order. Got? Now we'll be moving on to the next problem. If magnitude of A vector plus B vector equals to magnitude of A vector minus B vector, prove that A vector and B vector are perpendicular. If it is perpendicular means you have to prove that A vector dot B vector must be equal to 0. So to be prove that, okay? To prove that A vector dot B vector is equals to a 0, you are going to get it as. Now let us take whatever they have given. A vector plus B vector, magnitude will be is equals to magnitude of A vector minus B vector. You can have squaring on both the side. Magnitude of A vector plus B vector squared is equals to magnitude of A vector minus B vector squared. Now let us expand this one. You are going to get magnitude of A vector squared plus magnitude of B vector squared plus 2 into magnitude of A vector into magnitude of B vector. This is according to A plus B whole squared, and this is according to A minus B whole squared, which is magnitude of A vector squared A squared plus magnitude of B vector squared B squared minus 2AB. 2 times of magnitude of A vector into magnitude of B vector. You know already the positive signs or the negative signs of each other in the equal symbol will be getting cancelled. Now plus A magnitude squared and plus A magnitude squared will go. Similarly plus magnitude B squared plus magnitude B squared will go, and let us take this minus 2 to this side, which will become plus 2. 2 times of magnitude of A vector into magnitude of B vector plus 2 times of magnitude of A vector into magnitude of B vector will be is equals to 0. Otherwise 2 plus 2, which is nothing but 4 times of magnitude of A vector into magnitude of B vector will be is equals to 0. You can cross multiply 4. 0 by anything will be 0 only. Therefore magnitude of A vector into magnitude of B vector will be is equals to 0. So proving that A vector and B vector are perpendicular to each other, That's it. Okay. So if they asked you to prove the parallelism, then you have to prove cross product will be is equals to 0. If A vector cross B vector equal to 0, then they are parallel to each other. If A vector dot B vector equal to 0, then they are perpendicular to each other. So okay dear students, I hope you've understood the easier level problems how to solve by vector product. So in the next session, we'll be moving on to the next concept of the vector algebra. Until then, keep watching dear students. Thank you. Have a nice day.